First, we look at minimization of functions of a scalar variable. Let's look at an example. F of x equals minus x plus 2 times x minus 2 cubed times x plus 1. The plot of the function looks like this. And we ask the question, what is the minimum value of this function? Clearly, at the right end, the function goes off to minus infinity. So the smallest value, or the minimum value of the function, is minus infinity. But generally, we are interested in local minimizers, like this point x star. A local minimizer means that in the neighborhood of that point, there are no points where the function has a smaller value than at that point. So recall from calculus, if x star is a local minimizer, then f prime of x star, the derivative of the function evaluated at x star, equals 0. This is a necessary condition. We note that this is a necessary condition. That means if x star is a minimizer, then f prime of x star is 0. The other way around is not true. We can think about why. So in this example, f prime of x star, if we calculate the derivative and collect terms and so on, we get minus x minus 2 squared times x times 5x plus 8. And if we set that equal to 0, there are 3 candidate solutions for x star, 2, 0, and minus 8/5. Of these, how do we determine which one is a local minimizer? That's given by a sufficient condition. So if f prime of x star is equal to 0 and f double prime of x star is greater than 0, then x star is a local minimizer. F double prime is the second derivative of f evaluated x star is positive. This is a sufficient condition. So in this example, if we evaluate f prime of x, f double prime of x, that's minus 20 times x minus 2 times x minus 4/5 times x plus 1. So if we evaluate f double prime at our 3 candidate solutions, f double prime of 2 is 0, f double prime of 0 is minus 32, and f double prime of minus 8/5 is positive, which says that minus 8/5 is a local minimizer. We can also see that from the plot. So let's compare this discussion with our discussion on stability from the last assignment. So if f is energy, then f prime of x equals 0, we recall, gives equilibrium. And f double prime of x greater than 0 implies stability. So all this discussion says that a stable equilibrium point is a local minimizer of energy.